Alrighty, folks, watching this video, we went through this kind of a little bit in class already, so I'm going to go kind of a little bit faster through 3-7, but here is the homework, 2 through 36 evens. There you go. Ready? Alright, starting at the top, we've got, I'm going to go through these kind of fast. Parallel lines. Parallel lines look like this, or two lines that are not going to touch each other, right? Okay? Then we have parallel planes, which are flat surfaces that are like one on top of each other, right? So these would be like floors in a two-story building, right? Like the floor here and the floor here are hopefully not going to touch each other, right? The floors, yeah. But then we have something called skew lines. I know you guys have heard that before. We did that like on the floor here. But this would be like two flat surfaces, but one on top of the other, and we have lines going different directions, right? So they're on top of each other in like three-dimensional space, but they're not parallel and they're not perpendicular. They're just skew. They're kind of like floating around, but they're never going to touch, right? Okay? So there is that. All right, let's go down to example 1. Identify each of the following using the cube shown. All lines that are skew to BC. BC is this one right here. So I want all lines that are not going to touch line BC.
That includes parallels, right?
Okay. No, not parallel, just skew. Just skew. Okay? So they say AF is one. I'll do this in a different color. AF is skew. They say DE is skew. They say FG, this one is skew, right? They say what else? EH is skew. Yep. What about FE? This one right here.
That's parallel.
They are technically parallel, right? Okay. Anything else that is skew? I think all the other lines are going to touch them, actually. Is AD skew?
No, parallel.
No, he's parallel. All right. All lines that are parallel to EH. EH is this one right here. What else is parallel? How many other lines are parallel to that one? 3. CD, AB, and FG. We're missing FG. There you go. Okay? Those are parallel. They're going the same slope, right? All right, next. All planes. Planes are flat surfaces that are parallel to plane DCH. DCH is this side right here. How many other planes are parallel to this one over here? Only this other side over here. But we only need 3 letters to designate a plane. Let's go 3 letters. What? ABG. Sure. Okay. These two are parallel to each other. And those are the only 2 ones that are parallel. Got it? Okay. All right. Now, when you guys did your like little diagram on the floor just now, I had the 2 lines that are like, it was the lines that like Colton and Dylan were on this side, right? And Kellen and who was the other one on that side? Zach was on the other side. Okay. You guys were making 2 parallel lines, right? Okay. They don't have to be parallel in order for this to happen. So imagine that those 2 lines that you 4 boys were forming were those 2, and then this was Simon in the middle, right? These 2 do not have to be parallel. But we'll talk about what happens when they are parallel, okay? If this happens, we have like alternate interior angles, right? Okay, alternate interior would be 4 and 6. They're on opposite sides of your transversal, but they are inside of the parallel lines, right? Let's maybe do this first. The interior is here and the exterior is out here, right? So I have 4 interior angles. They are 4, 3, and 5, 6, right? And then I have 4 exterior angles. They are 1, 2, and 8, 7, right? Like inside of the train tracks versus outside the train tracks, right? But then alternate means alternating on either side of my transversal that's going through here, okay? If they're alternate interior, they're inside the parallel lines, but alternate means opposite sides of the transversal. That would be 4 and 6 and 5 and 3. They're on opposite sides of the transversal, but they're inside the parallel lines, right? Okay, list me the alternate exterior ones. These are like pairs that go together, right? Like which one goes with 1? 1 and 7 goes together, right? Okay, because they're opposite sides. 2 and 8 go together, right? So there's 2 sets of alternate interior and there's 2 sets of alternate exterior. True? Okay. All right, then we have something called the consecutive interior. Consecutive means on the same side of the transversal. So here's my transversal. I want interior ones that are on the same side of the transversal. So what goes with 4? 4 and 5 would be consecutive because they're on the same side. What would go with 3? 6, right? Okay, 3 and 6. All right. I have consecutive exterior. They don't do these a lot for some reason. Oh, exterior. Okay, list me my consecutive exterior.
1, 2, and 7, 8.
1 and 2 are, wait a second.
1 and 8.
1 and 8, right? 1 and 8 would be together, and 2 and 7 would be together. But that's 2 sets each, right? 2 and 2, got it? Okay, let me erase and let's go over here. What else do we have? Oh, corresponding. We have something that's called corresponding. Okay? All right, here's my corresponding. Corresponding means in the same corner of the intersection. So we have our intersection here, we have an intersection here. So like 1 is in like the northwest corner of that intersection. What's in the northwest corner of the other one? 5. 1 and 5 would go together, okay? 2 would go with 6, right? 2 and 6 would go together. They're in the same like corner, right? 3 would go with 7 and 4 would go with 8. Now, as far as corresponding angles, how many pairs of corresponding angles are there? 4 pairs of corresponding angles. All the other ones have 2 pairs. Does that make sense? Right? Okay, and then we have, let's go vertical angles. You've already done these. Vertical angles. Vertical ones meet across from each other. So 1 goes with what? 3. 2 goes with 4. 5 goes with 7. 6 goes with, how many pairs of those are there? 4, right? Yeah? Let's talk linear pair. There's a ton of those, right?
8.
Linear pairs. Give me a set of linear pairs.
8, 7, 7.
8 and 7 are a linear pair, right? Because they live on a straight line. 8 and 7 go together. 7 and 6 go together. 6 and 5 go together. 5 and 8 go together. That's 4 pairs just in that intersection. So how many total pairs of linear pairs are there?
8.
8. 8 total pairs, right? Okay, do you see how this works? All right, did I miss anything? Blah, 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 blah. Interior angles, exterior angles, all the things. All right, here we go. Classify each angle pair relationship. All right, here we go. 4 and 5. All right, here is my 2 lines. They don't have to be parallel, but there's that. My interior is here. My exterior is here, right? Okay, do you see how that works? Interior, exterior. You see like the panel going through, right? Okay. 4 and 5, they want to know what the relationship between those two are. 4 and 5, what are those angles? They're alternate, they're on opposite sides of the transversal, but they are interior, so they are alternate interior. If you want to abbreviate ALT-INT, that's fine. Okay, let's talk 3 and 7. 3 is here and 7 is here. Those are in the same corner of the intersection, so those are corresponding. Okay, yeah? All right, do a different color. 3 and 5. 3 is here and 5 is here.
Interior pair.
They're both interior, right? But they're on the same sides of the transversal.
Consecutive interior.
They are consecutive interior because on the same side of the transversal. So consecutive interior. All right. Then let's talk 1 and 8. Ooh, let's see. 1 is here and 8 is here. What?
Exterior.
Alternate exterior. Do we know these already? Are these like embedded in your brain? Not too bad. Okay. All right. Now we've got like a bunch of lines going on right here. What is the name of this line? Oop, what's the name of this line right here?
D.
D. Do you see that? Down in the bottom corner? Okay. What's the name of this line right here? E. Okay. What's the name of this line? F. What's the name of this line? G, right? Okay, so, and then they have some of these angles numbered, like this is angle 1, this is angle 2, etc., right? Okay, they want to know what is the transversal, so like Simon was the transversal, that connects angle 1 and angle 8. Angle 1 is here and angle 8 is here. Which one is the transversal that's touching both of them? F is the only line that's touching both of them. So here would be like my parallel lines, right? Okay. 1 and 8, the transversal is F. What's the relationship between 1 and 8? They are corresponding, right? They're in the same corner of the intersection, corresponding. All right, let's talk about the transversal that connects 3 and 6. Okay, 3 is here and 6 is here. Which line touches both of them? G, that's the transversal. Okay, here's my parallel lines. Okay, so we're going to completely ignore this one over here. 3 is here and 6 is here. What are those? They're alternate exterior. Yeah? Okay. And then we've got 6 and 7. Let me erase. Blah, blah, blah. 6 is here. 7 is here. The one that connects both of them is E. Okay. These are my 2 parallel lines. What's 6 and 7? They're both interior, but what kind of interior? Consecutive interior, right? Consecutive means same side of the transversal, interior. Consecutive interior. Got it? Not too many on this section. I don't even think I assigned you any. Okay, now, here is the fancy thing. Are you ready? We talked about this on Friday. Now, they're saying, okay, if these two lines are parallel, now we have something even extra special about them, right? These are still, 7 and 3 are still alternate interior angles, but what's true about 7 and 3? They're going to be the same measure, right? If 7 is 140 degrees, 3 is going to be 140 degrees. As long as those two lines are parallel. If it's not parallel, and if this one's going this direction, obviously that's not going to be true, right? But that's going to be the same. All right, 2 and 6 are also alternate interior angles. Are they going to be the same? What are they going to be? What are 2 and 6 going to be?
40.
They're both going to be 40, right? Okay. Now, what about, let's go this one right here. Let's say angle 1 versus angle 3. What are those guys in relationship?
Same thing.
They're corresponding. They're in the same corner of the intersection. But are they going to be the same measure? Yes, as long as those lines are parallel, right? Okay. What about this one? Let's do this one. What about 2 and 3? Are they going to be the same?
Pair.
They're not a linear pair because they're not living on a straight line, but they are
Consecutive?
supplementary, is what you wanted to say, right? Supplementary means they're going to add up to be
So what?
180, right? So here's the deal. Is everybody listening? This is the key. If these two lines are parallel, every single pair of angles will either be the same measure or add up to be 180, supplementary. Does that make sense? As long as those two lines are parallel. It's one of two things. Like it's a 50-50 shot. Either they're the same measure or they add up to be 180 and that's it, right? Okay. So that's what they have going on down here, blah, blah, blah. They're just saying those are all the same. Let's do this. All right. Using theorems about parallel lines, blah, blah, blah. Okay. Angle 1 is 42 degrees. Do you see him? 42 degrees is angle 1 right there. Okay. They say find the measure of angle 7. Okay. 7 is over here in this corner. Do you see them?
90.
Roop. 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 Okay. 42 is there. 7 is here.
That's 90 degrees.
7 is 90 degrees? I don't think so.
Yes, huh? Look at the railroad track.
These two are parallel. They just don't maybe look parallel because there's like
42.
whatever.
42.
Is angle 7 going to be 42 degrees?
Yes.
In real
Yeah.
life,
What are those two angles?
Congruent.
They are?
All into exterior.
They're alternate exterior, yeah?
well, in real
Okay.
life, that
They're
is-
on opposite sides of the transversal, but they are like exterior, right? Okay. So angle 7 will be 42 degrees because alternate exterior. Yeah? Okay. Now, they're going to give us values. Imagine that angle 3 is 4x plus 7, and angle 6 is 5x minus 13. We have to decide one of two things is going to happen. Either they're the same measure, or they add up to be 180. 3 and 6, are they going to be the same measure, or are they going to add up to be 180?
Same. They're all interior.
They're alternate interior angles, so they're going to be the same measure. So, what do? 4x plus 7 equals 5x minus 13. All right, I'm going to subtract 4x, and I'm going to add the 13. 7 plus 13 is 20. Ooh, 20 equals x. X is 20. Do I have to plug back in? Find x. That's it. Yes. Okay, and we used alternate interior angles theorem. Okay, good. X is 20. X equals 20. Oh, they have it right there. Right there. Okay. Oh, hold on. B. Just wait. We got one more. Hold on. We got one more.
We don't need it.
We do too. No, you just wait. The measure of angle 8. Hold on.
Senior.
The measure of angle 8 is 68 degrees. The measure of angle 3 is 3y minus 2. Okay, we have to decide. Angle is this guy right here. Angle 3 is this guy right here. Are they the same measure?
Yes. We just proved the last one.
Angle 8 is here and 3 is here, right? Okay, let's do this. Let's hop from angle 8 to angle 4. Those are corresponding angles, right? Angle 4 would be 68 as well, right? This should be 68, true? But then these two have to add up to be 180 because they are a linear pair, right? So, how do I solve this?
Do math.
3y minus 2 equals
3y minus 2
plus 68.
plus 68 equals 180? Sure, we could do it that way. That's fine. Okay. let's, I don't know, subtract the 68. Some of you guys went straight to here and you said 3y minus 2 equals 112. Is that 112? So some of you guys did the math in your head. And then we add the 2. 3y, can you do this in your head? 3y equals 114. Can you divide by 3 in your head?
70.
You can too. 11 divided by 3 is 3 with 2 left over. That's 24 divided by 3 is 38. Can you do that in your head?
No?
Are you kidding me?
That's
Did you follow that?
Yeah, but like.
Okay,
No.
114 divided by 3, right? How many times does 3 go into 11? 3 times, which would be 9, so that would be 24, right? And 24 divided by 3 is 8. 38. You can do that in your head.
I can't.
Yes, you can.
I never.
Yes, you can. Oh my gosh, that's exactly what you would do. You just don't write it all out, all the
I
steps.
stopped doing that in like 4th grade.
That's when you stop doing math, Jace.
What's 175 divided by 5?
Shut up.
What's 175 divided by 5?
35.
Yeah, look at you go. As 5 goes into 17, 3 times, that would be 15, right? So 25 left over, and that would be 35. You look at that. You can do those in your head. Don't waste your time using a calculator. All right, do 2 through 36 evens, go.
Can I